Hello and welcome back to another Chemistry Academy video. In this video we're going to go over the chemical industry and process design.
So it really is a bit of common sense, but this kind of summarises it all, and most of the time you'll really be asked about it in open-ended questions if you're asked to discuss it, or sometimes you can be shown a given process and asked how you could make it more economical, or if there was an issue, they might ask why something was an excess, why something was limiting, or why highly exothermic reactions need to be controlled. So this should cover all of those things. So when you're designing an industrial process, the main aims is that you're maximising your profit and you're also minimising any environmental impact and also making it safe. So when it comes to then designing the process, when you're looking at feedstocks, so they're the raw materials that you put into the reaction, so they're basically your reactants, you'd want them to be relatively cheap, so obviously that would maximise your profit if your raw materials are cheap, and then also widely available. So if they're widely available, they tend to be cheaper, which again would maximise your profit. And also then they would usually have less environmental impact as well. If there's lots of them, it's not like they're going to go scarce or anything like that. Like if it was a rare metal, that could eventually run out. So widely available cheap feedstocks are ideal. If you do have a reactant that's more expensive or unsafe, or rare, then you should ideally make that one the limiting reactant. So that means it'll get completely reacted and none of it will be wasted. Using recycled or renewable feedstocks is also beneficial for the environment because it means we're minimising waste. And waste can also be very expensive, so if you're minimising waste, you're usually maximising your profit as well as helping the environment. When it comes to then byproducts, so byproducts are things we make in the reaction that we're not intending to make, and they usually, when you're shown an industrial process, come off the side of it. So you can usually recycle them somewhere earlier in the reaction. That's a common thing that you get asked about. If you're asked how the reaction can be made more economical, is usually recycling a byproduct somewhere else in the reaction. So just look for the things that appear twice. Sometimes though, if your byproducts aren't involved in that particular process, there's sometimes another process that the company might be running where it will be involved, so they can recycle it there. And failing that, you could always sell it to somebody else for them to use, so you could make profit from your byproducts. So if you do see the phrase how the process can be more economical, it usually is to do with recycling a substance within the process. So like I said, just look for it appearing more than once. Then when it comes to the running costs, so you can use a catalyst. So that would allow you to run your reaction at a lower temperature, which therefore lowers your cost because energy and heat cost money. So if you're not having to heat the reaction as much, then that will cost you less. But also then there's a lower risk of explosion, which is obviously safer for the people working in your industrial process plant. Then, like I said, they can quite often ask you about highly exothermic reactions and why they need to be controlled. So if they're not correctly controlled, then they have a high risk of explosion, which obviously is not ideal. So if you are asked about that, that's what you need to say about that. When it then comes to the running of the reaction as well, you want to make sure you've got a high atom economy. So atom economy is the percentage of your reactants that end up in your product. So if that's high, it means you're not having much waste. You obviously want a high percentage yield as well, because that means you're making the most amount of profit, most amount of product. So again, it's minimising waste and it's also maximising your profit because you're going to have more product to sell. And then lastly, you'd want to make sure you fully react any dangerous chemicals. So this is something else they'll sometimes ask about. They might say, why does the chlorine, if it was to do with bleach, why does the chlorine need to be limiting? And it's because chlorine gas is dangerous, it's hazardous to human health. So you would want to make any dangerous chemicals the limiting reactant so that they fully react and then it's not exposing people to the dangerous chemicals. So that's essentially the rundown on the process design. you would, on an open-ended question, want to elaborate on a lot of these bullet points. But like I said, a lot of it is common sense, just discussing how all of these things help to maximise profit and minimise environmental impact and improve safety. So if we look at this process here, just to finish off, so this is what the industrial processes tend to look like in the SQA exams. So you've got, these are your feedstocks here, the raw materials you're putting into the reaction. Carbon dioxide is widely available because it's in the air, and as we know, we produce a lot of it at the moment. And then ammonia is generally widely available as well because it's made in the Haber process on an industrial scale, so it's quite easy to get your hands on ammonia too. So in terms of making this process more economical, again, we're looking for things to recycle. So these would be your byproducts here. So you could recycle this ammonia and carbon dioxide that's produced as a byproduct back into the start of your reaction. So you could put those back in here, and that would make it more economical because you're minimising waste. You could also recycle this water in here, because again, you need water in this stage and you're producing it as a byproduct here. So just make sure the arrow's going out the way. That means it's a byproduct that's being produced, and then you recycle it back in where it is needed somewhere else. You may also think, oh, you could recycle the urea from here to here. However, the process is trying to make urea, so you wouldn't recycle that because that is actually your desired product. That's what you're trying to make. Other ways that you could make this more economical that aren't necessarily shown in the picture is using any catalysts in the reactors if possible, which would lower the running costs, so you wouldn't need to heat it as much. And yeah, selling any byproducts if you weren't going to recycle them. So if there was a byproduct you produced that wasn't actually in this process anywhere, then you could sell it for profit or recycle it in another reaction. So I hope that helps, and if you found this useful, please give it a like and don't forget to subscribe.